Okay, we are ready to go. I believe they are posted. Let me double check and see. Find where these guys are. Yeah, so what it is they are linked on the class schedule page, but I can go ahead and just do a new post here. Here. Okay, so it should be also posted to Schoology too in case you can't find it on the class schedule. So let's talk domain and range. Yesterday we looked at how to graph everything. Today we'll look at how to find domain and range, and we'll do it in two ways. So you can do it without graphing the function, or you can do it once you've graphed the function, and then you can kind of just look to see what the domain and range look like. But remember, domain is the set of values that are on the x-axis. So so for example, here we have this graph, and let me kind of erase what we have around here so we can just see the graph in red here. If I were to trace the graph, I would start on the left side, somewhere far out here, infinitely in that direction. We know that it's continuous, so all the way out to infinity, we have x values there. All of those x values are included until we get to this hole where we're going to skip, what is that, 1, 2, we're going to skip -2 as an x value. So -2 doesn't exist here, but then even -2.000001 and -1.9999999 repeating, the closest possible point is still going to exist in the domain. The only number that is not going to exist is -2. So we're skipping over -2, and then all of these x values until we get to the asymptote. So this graph is still going to be getting super close to that asymptote. This asymptote is at x equal to 3. So it means we're talking about 2.9999999 infinitely, continuing. Super close, but never actually going to be touching x equal to 3. And then we jump over to the other side, and same thing, this graph is going to continue getting closer and closer and closer to x equal to 3, but it's never going to actually touch that value. However, it's going to get super, super close. So, and after that, it continues infinitely. So when I write out my domain, I will start from negative infinity. And then, like I said, from negative infinity, our domain gets cut off at -2. So I'm writing this notation here. So this is our interval notation. We see that negative infinity is starting on the left side. It goes all the way up to -2, but not including -2. So that's why I did a open parentheses here. So that means we're gonna go all the way up to -2, but not include -2. So it's different from saying negative infinity, sorry, not -1, to -3. Some people might have the kind of instinct to do that and then maybe to go like this, right? Negative infinity to -3. That would be true if we were just talking in terms of whole numbers, right? Because if you were to stop at -3, then obviously you'll be leaving out -2. However, if you stop at -3 in this case, and in every case, because we have all those points in between, the decimals in between, we need a way to be able to account for that little space that's between -3 and -2. So instead of this notation, we do the notation that we had, -2, not including 2. So that means we're talking everything from negative infinity all the way up to -2, but not including -2. Okay. So that's that first piece that we see there. And then after -2, so we're going to union it. And again, we're going to start it at -2 for the same reason. We don't want to start at -1 because then there's that whole little gap that we'll be missing. So we want to start with -2, but not include -2. And then we're going to go all the way up to +3, because +3 is where the asymptote, the vertical asymptote is. And so we cut it off, we union it, and we keep going. So the next piece that I have that is just continuous there is going to go from +3 to infinity. So that completes our full domain from negative infinity to infinity, but there's going to be 2 spots where the graph breaks. And those 2 spots are at -2 and at 3. Okay. And you can see kind of if I were to color this, right, this first chunk is this first set of parentheses, or first interval, I should call it. Then you have the next chunk, that's that interval, and then the last one, 3 to infinity. So you should be accounting for your whole graph in this case, okay? Are there any questions on that part so far? Okay, so we just did that graphically by looking at the graph and seeing where it breaks. So how can we do this without having to look at a graph? Well, there's our domain, if there's no continuities, is always going to go from negative infinity to infinity, right? A line goes from negative infinity to infinity. But when you start to break that up with holes and asymptotes is when our domain starts to break up. So we want to determine what kind of discontinuities break up the domain. And so the discontinuities that break that up are going to be the holes and only the x value of the holes. So in this case, right, the x value of our hole was -2. So that's why -2 broke up our domain. And then vertical asymptotes. Okay. So vertical asymptotes and holes are going to be the two things that break apart our domain. So let's take a look at number 1. And let's not look at the graph for a minute here. Right. So I look at my discontinuities. I see that I have a hole and I also have a vertical asymptote. So I know that those are the two things that are going to break up my domain. So what I want to do is I want to see what those values are. For the hole, it would be 5, and the asymptote is -3. So you want to make sure that you get those in order first. Since we're going from left to right, from negative infinity to positive infinity, -3 is going to come first. So when I go to write my domain, I'm going to say it's from negative infinity to -3. And then I'm going to union that. And we'll go from -3 to then the whole, which is at 5. And then I'll union that. And since there's no more holes or vertical asymptotes, then it goes to infinity. Okay, so let's double check that with the graph and see that that makes sense here. So the first piece here from negative infinity to -3 is going to be this chunk of graph right there, which makes sense. We see that there's the vertical asymptote at -3, so that works. And then we're going from -3 to 5. Let's see here, -3, and then all the way to 5 is where the hole is. So that makes sense there. We have a whole continuous piece there. And then lastly, 5 to infinity. And that's going to be 5 to infinity there. Okay. So as long as you know the holes and the vertical asymptotes of your graph, then you can just place those in order from least to greatest, and that's going to give you your domain. Sometimes you may have more than one holes or more than one asymptotes. So just take all of those values, put them in order, and it's going to break up your domain just the same way that we that we see here. All right. Ready for range? Any questions? Let me know. So let's talk about range here. Oops. Oops. Erase that. Range is all of our y values. So what I'm going to do, I'm going to start with negative infinity as the y value. So this is our y-axis. Negative infinity is going to be way down here. we know that this graph is going down in this direction. So all of these y values are going to exist, starting from negative infinity, going up and up and up. So all of these x values here are going to be part of our range, and up until here at the x value of our whole. So our whole is at 8/5. So I know that that is going to be breaking up my range right here. Because if I look really closely, right, the graph is going to be cut off at 8/5, but then right after that, it's picking right up. So the point that's like right after that, that little decimal up, that's going to exist. So when I write my range, I'm going to go from negative infinity to 8/5. And then after that, if I follow the graph, this graph is going to keep going, but it's not going to go higher, and it's never going to touch y equal to 2. So it's going to go from 8/5 to 2. And then after 2, this part of the graph is going to keep going this way. Nothing's going to happen after 2 over there. But remember, we're following the y-axis. So the y values stop over here, but they pick up over here. So the only value they're skipping over is 2, and then it's picking up and going up to positive infinity. So it's going from 2 to positive infinity, like that. And that is our range. So we can see the different parts here. This part from negative infinity to 8/5 is there. We've got this little chunk here from 8/5 to 2. And then we've got the last piece. Let's do this color. There, 2 to infinity. So for the range, what are the two things that are going to break it up? In this case, and in all of our cases for range, it's going to be the whole, but it's going to be the y value of the wholes. And then it's going to be the horizontal asymptote. So if you ever have a horizontal asymptote, then that's going to automatically break up your range. So going to example 1 here, again, let's not look at the graph. We're going to do this without using the graph. We're going to write out the range. So that means we need to find the wholes and the horizontal asymptote. So in this case, our whole has a y value of 1/8. And our horizontal asymptote has a y value of 0. So we'll put that in order from smallest to greatest. Smallest value in this case is 0. Biggest is 1/8. So we go from negative infinity to 0, union 0 to 1/8, union 1/8 to infinity. Okay. So looking at the graph, we can prove this graphically. So this first piece going from negative infinity and then stopping at 0, that makes sense. It's stopping right where that vertical asymptote sorry, not vertical, horizontal asymptote is taking place. And then we've got this chunk here from 0 to 1/8, because technically that piece is kind of a little bit lower, like it's getting a little bit closer to that vertical asymptote. Sorry, I keep saying vertical asymptote, to the horizontal asymptote as you go further to infinity, right? So we're saying that these are just a little bit higher than that little chunk at the very end, because that is going to keep going to infinity and keep getting closer and closer to that horizontal asymptote. So this piece here is from 0 to 1/8, and then that last piece from 1/8 to infinity is that big piece that's going to go all the way up. All right. So that is how we find our domain and our range. We are going to do one more example, because when you have an oblique asymptote or a slant asymptote, it does kind of change things up just a little bit. But this is the case where you don't have a slant asymptote, you have a horizontal asymptote. So those are the 4 things that you want to look for. For the domain, 2 things are the hole with the x coordinate and the vertical asymptotes. For the range, it's the y value of the hole and the horizontal asymptote. Okay, let's take a look at example B here. This one has, you can see it has a slant asymptote. The slant asymptote is not going to change anything when it comes to the domain. So the domain, we're still looking for holes and we're still looking for vertical asymptotes. This graph does not have a hole in it. It only has one vertical asymptote. So my domain is going to be from -infinity to -3, which is where that vertical asymptote is, and union -3 to infinity. So it's just these 2 pieces that are continuous here. Okay. Now the range here is where things get a little bit different. Remember that range counts for all of the y values. So if I pick any y value along the x-axis, on the y-axis, there should be a point that matches up with that on the graph. So for example, if I pick y equal to 5 here, there should be a place on the graph, which there is right here, where a point exists that has that y value. I can pick y equal to 0. There is actually 2 places in this case, here and here, where that y value exists. I can pick -0.5. Let's say that's -0.5 here, right? There's a place over here, and there's also a place over here on this side. So if we think about it on this graph, jumping back over here, +2 is one of the only places aside from the hole where I can say there's no place where I can find a point that matches with it. And that's because of that horizontal asymptote. But when we get a slant asymptote, like what we see here, it allows for our graph to still grow in either direction. So rather than there being one y value where it doesn't exist, what we can see is it allows for these y values to still exist and still grow, because we still have that kind of gradual growth, rather than if there's a horizontal asymptote, it just kind of stops and doesn't exist at a specific value. But here we're seeing that all those y values exist. So actually in this case, because there's no hole, our range is from -infinity to infinity, because all of those y values exist. There's no break or there's no place where a y value does not exist. Now this is going to depend a lot on the slope of that slant asymptote. This slant asymptote isn't as steep, so we can see that there's an overlap in the graphs, right? And that's why we have no break in y values that don't exist. Sometimes there may be graphs that, maybe look something like this. Let me do a different color. Say something like that. Oh, that's not what I want to do. Is that going to work? Nope, that's still going to overlap. So something like this, if I were to graph this here, what you can tell is that the graph on this side is going to keep going kind of in that direction. Oops, not straight line. Am I going that way? This is going to go kind of that way. And there's this whole chunk in between here. Right, kind of like this whole section here, where the graph is never going to cross through there, right? It just kind of goes in different directions, and then we have this whole gap. So we're going to see, I think, an example of that here. Yes, and we're going to kind of discuss that right now and see how do we kind of figure that out. So we have this gap. We want to be able to kind of skip that part and write out what that range would be. So, sorry, let me check something with my attendance real quick. Okay. All right, so let's take a look at this one here. And actually, let's see really quickly the domain. So the domain, remember, doesn't change. If I see that there's a hole here and a vertical asymptote, those are the two things that are going to break up my domain. So in this case, my domain will have to be from negative infinity to negative 3, since that is the smaller value between the hole and the vertical asymptote, and then negative 3 to positive 1, and then positive 1 to infinity. So that would be our domain, and you can see that if I were to follow the graph here, that does kind of make sense because we have this chunk right here that's going from negative infinity to negative 3. This piece right there, oops, right there, stop it at the hole because there's no x value there. And then this last piece like that. All right, and then we're going to take a look at the range. So normally, because we're doing just like a rough sketch, we're not going to be able to get the exact kind of value. So we're just going to look at kind of what we would have to do if we did know the exact value. If it's our own sketch, there's going to be some examples where I'll give you a graph and you'll know the points exactly, so you can find the exact range. In this case, I'm not too worried about it because we have kind of like our rough sketch here. So what we're going to do is we have a hole. So this hole is going to break up our range. And then also we have this whole piece here. All of this that is not a part of our range. So our range is going to go from negative infinity, because we do have this piece here that's continuing downwards. And then it's going to stop at this coordinate here. Now remember, we did like a rough sketch, so we don't know exactly what this is, but just for the sake of kind of writing things out right now, I'm just going to estimate and say that this is going to be at 1, 2, 3. Let's just say -4, right? Roughly. We'll leave it at that for right now. It's just a rough estimate, but let's say from -4. And then we're going to union, and we're not going to write -4 because there's not any piece that comes after -4. The next point actually doesn't come in until this point right here, which is at 0. So I'm going to go from 0 to that hole, which is, it has a y value of 9/4. And then after that hole, we go 9/4 to positive infinity. So we see that chunk that is missing is being represented right here between -4 and 0. And yes, thank you, Thomas. This should be closed because we want to include those 2 points. So I'm going to go ahead and change that. There. Because we are actually including those points. It's that whole chunk in between that is not going to be included. So this would have to be our range here. We have that little chunk missing between -4 and 0, but the whole, we're only skipping over 9/4. So that's why we have these open brackets there. And it's 9/4 and 9/4. All right. Any questions there on that part? I know that kind of makes things a little bit trickier, but hopefully it makes sense the way we have it written out here. There will be some examples like on Friday, might as well let you know now. There's going to be a quiz on finding all of these different parts: holes, vertical asymptote, zeros, y-intercept, horizontal oblique asymptote, domain and range, and graphing. So as long as you can do it all on your own, like what we're seeing here, you'll be fine. I may give you a graph, and then you have to find the domain and range from that graph. So if you have something like this, you'll know the exact coordinates of that, so you'll have an exact range. Or I may not give you a graph, and maybe you just have to find it from the equation. And so in that case, I wouldn't give you a problem where you wouldn't be able to easily find those coordinates. So it might be something a little more along these lines with the horizontal asymptote, or possibly with a slant asymptote, but a slant asymptote that is still going to be from negative infinity to positive infinity for your range. So we'll have a quick quiz on Friday. I haven't decided yet. I want to try out Nearpod. Nearpod has a kind of quiz thing that I can do. So I might do it through Nearpod. Otherwise, it'll probably be through Schoology. It'll be, I don't know if you've done any of those written assessments, but it'll probably be multiple choice together with writing out your work for it. So just so you know, that's going to happen on Friday. To help you prepare for that, I have just this worksheet that I'll post to Schoology where you're just going to be going through basically all of these steps that we've been doing. So finding every single part that you see there, the holes, vertical asymptotes, zeros, y-intercept, horizontal, slant asymptotes, domain and range, and then graphing. So that's what we're going to practice so that when you have your quiz, you'll be ready to go. Most likely for your quiz, it'll be kind of like the quiz is, where it's just different parts. One question is asking about certain parts, so it's not just kind of all at once, but you'll practice it that way on the worksheet. Are there any questions regarding the quiz
If it's
or anything that we just saw here? Okay, so I'm going to go ahead and just share the assignment. Sorry, I'm trying to find my, oh, here it is. Need to stop this live stream.